Okay, so hello, namaste, and welcome everyone. Welcome to this tutorial session. Today we will be basically solving problems related to week 3. These will be some problems that might help you in basically solving your assignment problems, or problems that might come in your final evaluation. So these problems will be related to those things and the topics that have been covered in week 3 basically. And so let's get started. Let's see how many problems we are able to solve today. So the recording is already started. I'll switch to my iPad. Yeah. Okay, so I think for the online audience I also need to join from my iPad, so let me just do that. Okay, let me share my screen. All right, so we will solve. So we will get started. Let us see what are the problems that we need to do today. So this is week number 3. So week number 3. So the problems in this tutorial will be related to basically your different discrete distributions, probability distributions, mean and variance, in general movements. Okay, so mostly these two topics around which today's most of the questions will be around. Okay, so let's start with the first question. What is the first question? So should I write the question, or should I just explain the question? Okay, so let me just write. So maybe I will just explain the question and directly solve, because writing the question will take some time. Okay, so you are given a circle. Okay, and this circle has a radius of 1. Okay, now on this circle a point is randomly chosen on its circumference. Okay, so this is your, let's say this is your point x, and this is the x-axis, or the horizontal line around which the circle is made. So this point makes some angle with this line, right? Let me call this point as, let's say, a, and this angle as x. Okay, so maybe this angle is my random variable x. So since you are choosing a point at random on the circumference of the circle, the angle that it will make with the x-axis will also be a random variable, and that random variable is being called as x, right? Now it is given that x is coming from uniform 0, 2 pi. Okay, so we all know what a uniform distribution is. So all the points between 0 and 2 pi, all the angles between 0 and 2 pi are equally likely if it is coming from a uniform distribution, right? And the question that we are asked is, So someone is joining. So the question that we are asked is, what is the standard? Okay, what is happening? Just a second. Okay, someone is trying to join. Sorry, was there any question? So just a second, I think there's some issue with the Apple Pencil here. Let me just resolve it. Where is it? So it should be somewhere in settings here. The Apple Pencil is charged. Okay, just a second, give me 5 minutes. So okay, this charging is being shown. So why is it that it was not coming there? Yeah, okay, it's coming, fine, cool. Sorry for the, I think there was some issue. Okay, so for those who have missed, there is a circle of radius 1, and on that circle we are choosing a point at random, that let's call that point A, and this point A makes some angle with the x-axis, that angle is being referred to as x, and it is given to us that x is coming from a uniform distribution, uniform 0 to pi. Now the question is, basically, what is the distribution of this new random variable? What is the standard deviation of this new random variable y, which is given by 3 by pi times x plus 2? So the question is, what is the so maybe I can write, so standard deviation is denoted by sigma. What is sigma of y? This is the question. Okay, I think yeah. So any ideas how to do it? Feel free to maybe like just barge in the discussion. So I mean it's quite easy. So okay, so here we are being asked sigma of y. What we can do is we can first calculate sigma square, that is the variance of y, right? And then after calculating the variance, we just need to take square root to calculate the standard deviation. So let's see. So what is the variance of y? Now we can use some properties of this variance operator, right? So variance of y is nothing but variance y is equal to this 3 by pi times x plus 2, right? This is there. Then so now we know some properties of variance that we have studied. So variance of let's say ex b, what is that? If you remember, if you are doing some affine transformation on a random variable, the variance operator, how does it change? So if you don't remember, the variance of x plus b will be given by a square times variance of x plus b. So the shift doesn't just gets added. Okay. However, your the multiplicative term will basically will come out and get squared, right? So just keep that in mind. So if we apply the same thing,
I think sir, variance of b is 0, I think.
Yeah, you can look at it as that as well, because b is just a constant, it doesn't have any variance. That is also one way to think about it. But more like intuitive way to think about it could be that you are just shifting the random variable, and your variance is referred to as like variance deals with the kind of spread of a distribution, and the spread of a distribution is not affected if you are just shifting it by some amount, right? So yeah, I mean whatever suits you, whichever thing,
thing,
whichever
whichever
is intuitive to you, right?
to you, right?
So this
So
thing
this
will
thing
become
will become
3 by
3 by
pi
pi
whole square
whole square
times
times
variance
variance
of
of
x
x
plus 2,
plus 2,
right?
right?
And this
And
is
this is
9 by
9
pi
by
square
pi square
times
times
variance of x.
variance of
So
x. So
x is coming
x is
from
coming from
uniform 0 to
uniform 0
pi.
to pi.
So if you remember what is the variance of uniform random variable, so let's say
let's
x
say
is
x is
coming from
coming from
uniform
uniform
a comma
a
b.
comma b.
Do you know
Do you
what is
know
the
what is
variance
the
of
variance
x?
of x?
It is given
It is
by b
given by
minus
b
a
minus
whole
a
square
whole
by
square
12,
by
right?
12, right?
So here
So here
b is
b
2
is 2
pi,
pi,
a is 0,
a is
so
0,
2
so 2
pi
pi
whole, so
whole,
this will
so
be 2
this will be
pi
2
whole
pi
square
whole
by
square by
12
12
plus 2,
plus 2,
right?
right?
This is
This
nothing
is
but
nothing but
9 by pi
9 by
square
pi square
times 4
times
pi
4 pi
square
square
by 12
by 12
plus 2.
plus 2.
Now pi
Now
square
pi
gets
square gets
cancelled.
cancelled.
4 3s
4
are
3s are
12,
12,
3
3
are
3s
9.
are 9.
So this is
So
3
this is
plus
3
2,
plus 2,
6.
6.
Sorry,
Sorry,
3 plus 2,
3 plus 2,
5,
5,
right?
right?
Hence,
Hence,
uh,
uh,
oh, I think I
I
did
think
one
I did
mistake.
one
There
mistake.
should
There
not be
should
this
not
b,
be
right?
this b, right?
Because
Because
b is doing
b is
nothing.
doing
Sorry.
nothing. Sorry.
So this
So
will
this
just.
will just.
Okay, sorry. I
Okay,
am really
sorry. I am
sorry.
really sorry.
I
I
applied the mean
applied the
formula
mean
here.
formula here.
That's a mistake.
That's a mistake.
So this will
This
just
will just
remain
remain
3 plus 2.
3 plus 2.
This will just
This
be
will
3.
just be 3.
So I made one
I made
mistake.
one mistake.
I said
I said
there should be
there
plus
should
b
be
here,
plus b
but
here,
that is
but
not
that is
correct,
not
because
correct, because
if you are just
if you are
shifting
just
a
shifting
random
a random
variable,
variable,
the shift
the shift
doesn't
doesn't
contribute to the
contribute to
variance,
the
it
variance, it
contributes to
contributes to
the
the
mean.
mean.
Hence,
Hence,
this will just
this will
remain a
just remain
square
a
times
square
variance
times
of
variance
x,
of x,
and
and
here 2
here 2
will
will
not play any
not play
role.
any
So
role.
this
So
just the
just
scaling
the
factor
scaling
3 by
factor
pi
3 by
will come
pi
out,
will come
3
out,
by pi
3
square
by pi
times
square
variance
times
of x.
variance
Now
of x.
x is
Now
a
x is a
uniform random
uniform random
variable,
variable,
and
and
variance of a
variance of a
uniform variable
uniform
is
random
given
variable
by
is
this
given by
thing.
this thing.
You just
You
apply
just
that
apply
here,
that
get
here, get
this,
this,
do some
do some
calculation,
calculation,
and get
and
your answer,
get your
right?
answer, right?
So this is the
So this is the
variance.
variance.
This is so this is sigma square. You were asked about sigma, so sigma will be
will
just
be
root
just
3.
root 3.
Any
Any
questions?
questions? Maybe I
Maybe I
confused
confused you
you
a
a little
little
bit.
bit. If there is
If
any
there is
question,
any
please
question, please go
ahead
go
and
ahead and
just ask
just
it.
ask it.
If not,
If not,
we'll move
we'll move
forward.
forward.
So
So
here, so it was a
it
basic
was a
question.
basic question.
Most of the
Most of
question
the
today will
question
be
today
again
will be
basic
again
only.
basic only.
So here is a
So here is
second
a
question.
second question.
So okay,
Okay,
so there is a
there is a
city,
city.
okay,
Okay,
and there are
and there are
consecutive
consecutive
traffic lights
traffic
in the
lights
city.
in the
Okay,
city. Okay,
let's say this is
let's say this
traffic
is
light
traffic light
1, this is
1, this
traffic
is traffic
light 2,
light
and
2,
so on,
and
right?
so on, right?
There are
There are
you can
you
think of
can think of
like infinitely many
infinitely
traffic
many
lights.
traffic lights.
Okay,
Okay,
and
and a motorist
a motorist is going
is
to
going to
basically
basically
travel through
travel
this road,
through this
and
road,
he is going
and
to
he is going to
encounter each of
encounter
these
each of
traffic
these
signals
traffic
T1,
signals
T2,
T1,
T3, and
T2,
so on.
T3, and so on.
So at
So
each
at each
traffic signal,
traffic signal,
probability of
probability of
the signal
the signal
being
being
red.
red.
So let's
So
call
let's
that
call
random
that
variable
random
x,
variable
x
x
being
being
red.
red.
Okay,
Okay,
maybe
maybe
that is not
that
the
is not
right
the
way to
right
do
way
it.
to do it.
So let's
So
denote
let's
red
denote red
by
by
0
0
and
and
green by
green
1.
by
Okay,
1. Okay,
so
so
probability that
probability that
the
the
traffic
traffic
signal is
signal
red
is red
is
is
given to
given
us
to
to be
us to be
0.2, and the
0.2, and the
probability that
probability that
x
x
is equal to
is
1,
equal
that
to
is
1,
the
that is
traffic
the
light is
traffic light
green,
is
is
green,
given to
is
be
given to be
just
just
0.8,
0.8,
right? Because
right? Because both
these things
these
should
things
sum up
should
to 1.
sum up to
So
1. So
that is what is
that is
given
what
to
is
us.
given to us.
And
And
the question
the
that is
question that is
asked
asked
is,
is,
let me write it
let me
down.
write it
What
down.
is
What is
the
the
probability
probability
that
that
the
the
that the number of
number of
green
green
lights
lights
passed
passed
by
by
the
the
motorist before encountering red light is 4. So the question, so maybe I'll explain this question again. You are given multiple, there are multiple traffic lights, right? A motorist is going to start from here, and he is going to just pass through this road. So at each traffic signal he is going to encounter some signal. It is either red or green, and the probability of the each of these lights being switched on is given to us. And the question that is asked is, let's say he's going to encounter a red light at some point. Okay. What is the probability that before he hits this red light, he has covered, he has passed through four what is the probability that before he hits this red light, he has passed through four green lights? That is the question. So again, this is an easy question. Would someone like to volunteer maybe how to solve this? So it's not tough. It's quite easy. So you can think of it as follows. So how do we say it? So let's say this is the point where he encounters red. He has to pass through green, four greens before it, right? So this should be green. This should be green. This should be green. This should be green. So what is the probability of this sequence of events? Right? That's all that is being asked. So any ideas? Okay, so let's say that so in general, what is the probability of this x? So let's say y is the number of g's before an hour. So let us call that random variable as y. So what is the probability that y is equal to k? This is the question. It's quite simple. So if you want k number of g's before r, you have to basically ensure that all of the first k elements or k traffic lights are g's, right? And what is the probability of that? The probability of that is 0.8 raised to k. And you have to also ensure that the last one is red. So that is going to be 0.2. Okay. So this is like a geometric random variable. So this is actually following a geometric random variable with the probability of a success being 0.8, right? And we are asked what is the probability that y is equal to 4. This will be equal to 0.8 raised to 4 times 0.2. And you can calculate this using some calculator, right? Just put it in calculator and you can calculate what this number would be something in decimals. I don't know. Any questions? So I'm going a bit slowly today. Let me know at any point if something is not clear, right? Okay. So let's look at some other question. Third question. So x is a discrete random variable. Okay. And we have been given its PMF, probability mass function. So probability that x
probability
is
that
equal
x is
to
equal
n
to n
is given by this
by
thing.
this thing.
It is equal
It
to
is equal
minus
to
2c
minus
by
2c
n
by n
if n
if
is
n
equal
is
to
equal
minus
to
2 or
minus 2
minus
or
1.
minus 1.
It is
It
equal
is
to
equal to
d
d
if
if
n is
n
equal to
is equal
0,
to 0
and it is
and it
equal to
is
c
equal to
times
c
n
times n
if
if
n is
n
equal to
is
1
equal to
or 2.
1 or 2.
Okay.
Okay.
So x is
So
a
x
discrete
is a
random
discrete
variable.
random
It can
variable. It
either
can
take the
either take the
value so the set that it
set
can
that it
take
can
the
take
value
the
is
value is
in minus
in
2,
minus
minus
2,
1,
minus
0,
1, 0,
1 and
1
2,
and 2,
and the
and the
probability at
probability
each
at
of these
each of
points
these
is given
points
to
is
us
given
in
to us
this
in this
description, right?
description, right?
So the question
The
that is
question that is
asked,
asked,
and
and okay,
so
so
it is given
it
to
is
us that
given to us
c
that
and d
c
are
and
like
d are like
positive
positive
real
real
numbers.
numbers.
Another thing
Another
that is
thing
given
that is
to us
given
is
to us is
probability that
probability
mod
that mod
x
x
is less
is
than
less
1
than 1
is equal
is
to 3
equal
by
to 3
4.
by 4.
Okay.
Okay.
We are
We
asked
are asked
what are the
what are
values
the
of c
values
and
of
d.
c and d.
This is the
This is the
question.
question.
Any idea
Any idea
how will you
how will
start
you
solving
start
this
solving
question?
this question?
Okay.
Okay.
Again
Again
silence.
silence.
So
So
maybe I will just
maybe I will
start.
just
So
start.
whenever
So
you are
whenever
asked
you
such
are asked such
type of
type
question
of
to
question to
find the value
find the
of
value of
some
some
unknown
unknown
scalars,
scalars,
the
the
so there is
there
always
is always
so you need
so
to
you
make
need to
use of
make
some
use of some
information that is
information
given
that
to
is
you,
given to
which
you,
is this
which is this
information.
information.
Apart from
Apart
this,
from this,
you already
you
know
already know
something. What do
something.
you know
What do you know
already?
already?
You know
You know
that
that
probability of
probability
x
of
equal
x
to
equal to
I,
I,
and if I
and if I
sum
sum
this
this
over I
over
equal
I
to
equal to
whatever 0
whatever 0
to
to
whatever
whatever
so this is a
this is a
discrete, so
discrete. So
if you
if you
sum it over
sum it
minus
over
infinity
minus
to
infinity to
infinity, this should be
infinity, this
equal
should
to
be
1.
equal to 1.
This much
This much you know
because
because
the sum
the
of all
sum
the
of all the
probability should be
probabilities
equal
should
to
be
1,
equal to 1.
and in this
And in this
case you can
case,
use
you can
that
use
thing, right?
that thing, right?
Since you have in
Since you
minus
have
2
in
c
minus
by
2
n
c by
d
n
c by n,
d c
right?
by n, right?
You can
You can
just
just
add them up.
add them up.
So let's say
So let's say
probability of
probability
x
of
equal
x
to
equal
minus
to
2
minus 2
plus
plus
probability of
probability
x
of
equal
x
to
equal to
minus 1,
minus 1,
probability x
probability
equal
x
to
equal to
0
0
plus
plus
x equal to
x equal
1
to
plus
1 plus
tx equal to
tx
2.
equal to
This
2.
should be
This
equal to
should be
1.
equal to 1.
This is what
This
I'm
is what
saying,
I'm
because
saying
these are
because these are
the only
the
values
only
that
values that this can
this
take,
random
this
variable
random
can take,
variable
right?
can take, right?
And we know
And we
that
know that
these two
these
things
two
are
things
same.
are same.
These two
These
things are
two
same,
things are
right?
same,
It is
right?
given
It is
to us.
given to us.
For the
For
first
the
two are
first two
minus
are
2c
minus
by n,
2c
for
by n,
the
for
last
the
two are
last
c
two
by
are
n,
c
and
by n, and
the middle one
the
is
middle
d.
one is d.
So this
So
is
this is
d. So
d.
let's
So
write it
let's
down.
write it
So
down.
minus
So
2c
minus
by
2c
n
by n
times 2
times 2
plus d
plus d
plus
plus
the last
the
one was
last one
cn
was cn cn
times 2.
times 2.
This is equal
This
to
is
1.
equal
This
to
is
1.
given
This
to
is
us.
given to us.
So just
So
solve
just
it.
solve it.
What do you
What
get?
do you get?
Minus 2.
Minus 2.
So okay. So
You
you get 2
get 2
cn,
cn,
right?
right?
Plus
Plus
d
d
minus
minus
2c.
2c.
This is equal
This
to
is
1.
equal to
So
1.
this is
So this
the
is
first
the
equation
first
that you
equation
get.
that you get.
What is the
What is
second
the
hint that
second
we are
hint that we are
given?
given?
Oh, by
Oh,
the way,
by the way,
okay, it was
okay, it
minus
was
2c
minus
by
2c
n.
by
Oh,
n.
sorry,
Oh,
sorry,
sorry.
sorry. This was
This
n.
was n.
Okay,
Okay.
sorry.
Sorry. Just a second.
I
I
misread the
misread
question.
the question.
So it is
So it
minus
is
2c
minus
by
2c
n,
by
right?
n,
And
right?
n is
And
equal
n
to
is equal
minus
to
2 and
minus 2
minus
and
1. So
minus 1.
it
So
will be
it
minus
will be
2c
minus
by
2c
minus
by
2
minus 2
plus
plus
minus
minus
2c by
2c by
minus 1
minus 1
plus d
plus d
plus c
plus
times
c
n is
times
what
n
is
is what
given.
is given.
So c
C
times c
times
into
c
1
into 1
plus c
plus
into
c
2.
into 2.
This is what
This
it
is
is,
what it
right?
is, right?
So
So
minus this
minus
gets
this gets
cancelled.
cancelled.
This gets
This gets
cancelled.
cancelled.
So you
So
have
you
2
have
2 gets
2 gets
cancelled. C
cancelled.
plus
C
2c is
plus 2c is
3c
3c
plus d
plus d
plus
plus
c plus
c
2c
plus
is
2c
again
is again
3c.
3c.
This is given
This
to
is
be
given
1.
to
This
be 1. This
implies
implies
6c
6c
plus d
plus
is
d
equal
is
to
equal
1.
to 1.
This is your
This
first
is your first
equation, right?
equation, right?
So this
So
we
this
got
we got
from
from
your
your
basic
basic
uh, properties of
properties
your
of your
probability mass
probability mass
function.
function.
The
The
second thing
second
that you
thing
are
that
going
you
to
are
use
going
is
to
this
use is this
information.
information.
you are given that probability of mod x less than 1 is equal to what? 3 by 4. if this is
if
equal
this
to
is
3
equal
by
to
4,
3 by
what is
4,
the
what is
value
the
of
value
x
of x
that satisfies this thing?
this thing?
So x
So
can
x
take the
can take
value
the
minus
value
2,
minus
minus
2,
1,
minus
0,
1,
1,
0,
2,
1,
right?
2, right?
And
And
amongst these
amongst these
values,
values,
which are the
which are
values
the
that
values that
satisfy this
satisfy this
condition?
condition?
So if
So
you think
if you
about
think
it, this
about
is
it,
equal
this
to
is equal to
probability of x
probability of
equal to
x
0,
equal to
because
0,
x
because
equal to
x equal to
1
1
and x equal
and
to
x equal
minus
to
1
minus 1
correspond to the
correspond to
case where
the
mod
case where
x is
mod x
equal
is
to 1.
equal to
However,
1. However,
equality is not
equality is
given
not
to us,
given to us,
right? So
right? So
the only
the
left
only
value
left
is x
value is
equal to
x equal
0.
to 0.
Minus 2 and
Minus
2
2
are
and 2
like
are
mod
like
x.
mod x.
Mod of those
Mod
things
of
are
those
greater
things are
than 1,
greater
so
than
that
1, so
won't
that
count.
won't count.
This should be
This
equal
should
to
be
3 by
equal to
4.
3 by
And
4.
what is the
And what is
probability
the
of x
probability
equal
of
to
x
0?
equal
That
to
is
0?
given
That
to
is
us.
given to us.
That is given
That
to
is
us to
given
be
to us
d.
to be d.
So this
So this
implies
implies
d is
d
equal to
is
3
equal
by
to
4.
3 by 4.
This is your
This is
second
your second
equation. Just
equation. Just
use these two
use these two
equations. So if
equations. So if
d is
d
already
is
given to
already
you 3
given to
by
you 3
4,
by 4,
and
and
you know that
you know that
6c plus
6c
d,
plus
which is
d,
3 by
which is
4,
3 by 4,
is equal to
is
1.
equal to 1.
Now what
Now
you can
what you
do is
can do is
6c
6c
is equal
is
to
equal to
1 minus
1
3 by
minus
4,
3
which
by
is
4,
1
which
by
is
4,
1 by 4,
and hence
and
c
hence
is
c
equal
is
to
equal
1
to
by 6
1 by
times
6
4, which
times
is
4, which is
24.
24.
Right?
Right?
So
So
c is
c
1 by
is 1 by
24 and d
24 and d
is
is
3 by 4.
3 by 4.
This is
This is
how you
how
solve
you
it.
solve it. Any
Questions?
questions?
Maybe
Maybe you
just keep
just keep
asking
asking
questions
questions
if something
if
is not
something
clear,
is not
because
clear,
it's
because it's
possible that I am
possible
not
that I am
teaching
not
it
teaching it
correctly.
correctly.
Okay,
Okay, no
questions?
questions.
Okay.
Okay.
If there are
If
no
there are no
questions, I
questions, I
will
will
just
just
assume that
assume that
you are
you are
understanding everything.
understanding everything.
Next, let's
Next,
go
let's
to
go
the
to
next
the next
question.
question.
So this is
So
an
this is an
interesting
interesting question.
So
So
there are
there are
three
three
concentric
concentric
circles.
circles.
Okay.
Okay.
Let me
Let
draw
me
those
draw those
circles.
circles.
This is your
This is your
first circle.
first circle.
Make it a
Make
bit
it a
bigger.
bit bigger.
This is your
This is your second circle.
And there is
a third circle.
Okay.
Okay.
You are given
these three
circles.
circles.
Okay. Next thing is so these are all concentric. They have the same center. The radius of the first one is, let's say, R1. Second one, the radius of the second one is R2. The third one is R3. It is given to us that R1 is equal to 1 by root 3. R2 is equal to 1. And R3 is equal to root 3. Okay. This is given to us. So there are three concentric circles, and radius of each one of them is given to us. Now so there are more things that are given to us. What are those things? So let's say you are hitting a dart on these circles. Okay. So this is like a dartboard with three concentric circles. You are hitting darts on this dartboard. So basically, you are just picking a point at random on this plane.
Okay.
If you hit the innermost circle, so if you hit the innermost circle, you score some point. Let's call that point S1. So this is the score if you hit the innermost circle. If you hit this, the thing the region that is outside the blue circle, but inside the red circle, you score S2 points. And if you hit the point between this red circle and green circle, you score some score S3. Okay. And it is given to you that S1 is equal to 3, S2 is equal to 2, and S1 is equal to 1. So these are the pieces of information that is given to you. So again I will explain. So there is a dartboard with three concentric circles, and the radius of each of these circles is given to you here. and you are also given the score if you hit a particular region in the dartboard that is given to you here.
Okay.
Now
Now
the
the
probability
probability
of
of
so if
so
you are
if you are
hitting a dart at random,
random,
let's say you
let's
hit
say you
here.
hit here.
Sorry, let me pick some other
Pick some
point.
other
Let's say
point.
if
Let's say
you
if you
hit the
hit the point
which
here,
is
which is at some distance, let's say
which is at
some distance r. Okay.
the
The
probability that you hit a dart
and the
dart lands at a distance r from the center. So
the
probability
probability
of
of
x equal to
r
that is
that
given
is
to you.
given to
That
you.
is 2
That
by
is 2 by pi
into
into
1 over 1 plus
1 plus
r square,
square,
where r is
where
greater
r is
than 0.
greater
That
than
is
0.
given
That is
to you.
given to you.
So
So
basically, what is the probability that you hit a dart and the dart lands at a distance r from the center? That is given to you. That probability is this quantity. Okay. Now the question that is asked to you is what is the expected value of the score that you will eventually score basically. So if you hit a dart, you are going to get some points, right? This one of these points. So the question that is being asked is what is the expected score that what is the score that you expect when you hit this dart, given that the probability of landing at a distance r from the center is this thing.
this thing.
That is
That is
the
the
question that is
question
being
that is
asked to
being
you.
asked to you.
So it's simple. I mean, it is just little bit of calculation. So you know by the definition of expectation, right? You know that what do you know? You know that so if you want to find the expected score, right? It will be what? It will be basically summation of probability of score equal to some I into I, right? And I goes from 0 to 3, right? Because you can either score 1, 2 or 3 or 0. If it lands completely outside the dart, you score 0. So this is the expected value. Now you know what I is. I is basically 1, 2, 3 or 0. But you don't know what the probability of score being equal to I is, right? For that you can use this distribution. How will you go about it? So what is the probability that score is equal to 0? So you can score 0 if you land completely outside this green circle, right? What is the probability of that? So the probability of that is 1 minus probability that x, the distance at which you hit the dart, 1 minus probability x is less than or equal to root 3, right? So if you are inside this R3, which is equal to root 3, then you will score something. But if you hit the dart outside it is going to be 0. So the probability of scoring 0 is equal to the probability that you hit somewhere outside this dartboard, right? And that probability is basically given by this. So if 1 minus probability of x less than equal to 3, this is basically answering probability of x greater than root 3. That is all I'm saying. But this is easier to calculate. So what will it be? 1 minus probability of x less than equal to 3. You are given this probability distribution. Now this is so R is continuous here, so you cannot use simple summation. You need to use integration. So this will be 2 by pi into 1 by 1 plus r square. Sorry. 1 plus r square dr. Where r should go from where? 0 to root 3, right? So I am basically integrating the probability of landing inside this thing, right? if I calculate,
calculate,
so the probability of landing inside this thing will be exactly this thing, right? You're just integrating that probability over that region, and if you subtract it from 1, you get the probability of the complement, which is probability of x greater than root 3. And this thing, now this is some integration problem, 2 by pi. Now 1 over 1 plus r square, what is the integration of that? That is equal to tan inverse r, right? And you have to go from 0 to root 3 for this. So this will become 1 minus 2 by pi tan inverse root 3 minus tan inverse 0. Now tan inverse 0 is I think 0. What is tan inverse root 3? Is it it should be 1 minus 2 by pi I think this should be tan at 60 degrees. Is it 60? Let me think. So when does tan theta equal to root 3? It has to be minus 1 by 3, 2 by 3. Yeah, I think pi by 3. Right. So at 60 degree tan theta is root 3. So tan inverse root 3 will be pi by 3, which is 60 degree. Pi gets cancelled. 1 minus 2 by 3 is 1 by 3. Right. So P of S equal to 0 is equal to 1 by 3. Now what is the probability of S equal to 1? So S will be equal to 1 when it lands where? When it lands in S1. So wait. Okay, I think yeah. So I think this is S3, right? Yeah. So probability of S equal to 1, it has to land here in this green region, right? Because if it goes in red region, it will score 2. If it goes in blue region, it scores 3. If it goes outside this, it scores 0. So if it has to score exactly a score of 1, it has to lie in this green region, right? So what is the probability of that? So for that, you will just integrate the probability measure from you will just have to change the limits, right? So now you have to integrate from R2 to R3. What is R2 is 1 and R3 is 3. Root 3. So this will be again what is that? 2 by pi. 2 by pi into 1 over 1 plus r square dr, and r should go from 1 to root 3, right? Now this will be equal to 2 by pi times tan inverse r going from 1 to root 3. This will be again equal to 2 by pi times tan inverse root 3 minus tan inverse 1. The 2 by pi root 3 I just saw pi by 3. I think what will be this thing? Tan inverse 1 is 45 degree, right? Pi is 180. Pi by 2 is 90. Pi by 4 is 45. So this will not minus pi by 4, right? So pi gets cancelled. What will this become? 2 into 4 minus 3 1 by 4 is 12. This will become 1 by 6. So probability of S equal to 1 is given to be 1 by 6. So S equal to 0 is 1 by 3. S equal to 1 is 1 by 6. Similarly, what will be probability of S equal to 2? For that it has to land in this red region, right? Here. So what is the probability of that? Now you have to integrate from R1 to R2, right? So just do that. So integral R1 was I think 1 by root 3. 1 by root 3 to 1. 2 by pi into 1 over 1 plus r square dr. This will be 2 by pi. Now this will again be tan inverse, right? Tan inverse r, and the limits will be 1 by root 3 to 1. So this will become tan
tan
inverse
inverse
1 by root 3
√3
minus
minus tan inverse
of 1
of 1.
sorry
Sorry,
I think
I think opposite of this.
yeah.
Yeah.
And this will become 2 by
2
pi
by
times
pi times
pi by
pi
4
by 4.
tan inverse
Tan
1 is
inverse
pi
1
by
is
4
pi by 4
minus
minus
tan inverse
tan
1 by I
inverse 1
think
by
that
I
should be
think that
pi
should be
by
pi
6
by 6,
right
right?
pi
Pi
will get
will get
cancelled
cancelled.
2
2
into 6
into
minus
6
4
minus
2
4
by
2
6 was
by
the
6 was
24
24.
2
2
12s are
12s
this
are
become
this
1 by
become
6
1 by 6.
so this is
So this
p
is
of
P
s
of
equal
S
to 2
equal to 2.
so we have
So we
p
have
of
P
s
of
equal
S
to 0
equal
s
to
equal
0
to
S
1
equal
s
to 1
equal to
S
2
equal to
now
2.
the last
The
thing is
last thing is probability
s
of
equal
S
to
equal
3
to 3.
what is
What
that
is that?
that
That
again
again,
so for that you
for
have to
that you have
land
to
in the
land in the
innermost circle
innermost
which is
circle,
the blue
which is the
region
blue
right
region, right?
this thing this part
This part.
what is the
What is the
probability of
probability
that
of that?
this will be 2
This will
by
be 2
pi
by pi
into
into
1 over 1
1
plus
over
r
1 plus
square
r square
dr
dr
0 to
0 to
1 by root
1
3
by root 3.
so it's
So
just
it's
about
just about
changing the
changing the
limits and
limits and
calculating the
calculating the
integral that's all
integral. That's all.
I hope
I hope
you can see
you
that
can
there is
see that there
nothing
is
new here
nothing new here.
and I will
And
just
I will
skip
just
the
skip the
intermediate
intermediate
steps it will
steps.
be
It will be
tan
tan
inverse
inverse
1 by
1 by
root 3
root 3
minus
minus
tan
tan
inverse 0
inverse 0,
right
right?
this will be
This
2
will
by
be 2
pi
by pi
into
into
tan inverse
tan
1 by
inverse
root
1 by
3 is
root
pi
3 is
by
pi by
6
6.
yeah
Yeah.
and tan
And
inverse
tan
0
inverse
this is
0
0
this is 0.
so this
So
will
this
2
will
3s
2
are
3s
pi
are
pi gets
pi gets
cancelled so this is
cancelled. So
1
this
by
is 1
3
by 3.
so p
So
of
P of
s equal to
S
3
equal to 3
is equal to
is
1
equal
by
to
3
1 by 3.
so what do we
So what
have
do we have?
so now we
So
are
now
done
we are done.
so we have
We
this
have
thing
this
where
thing where
s can take
S can
values
take
between
values
0
between 0,
1
1,
2 and
2
3
and 3.
it is
It
given
is
to us
given to
that
us that
at
at
the
the
probability of s
probability of
equal to
S
0
equal to 0
and
and
s equal to
S
0
equal to
is
0 is
1 by
1 by
3
3.
so this
So
is
this
like
is like
1 by
1
3
by 3.
probability of
Probability of
1
1
being equal to
being equal
1
to
to
1 to
1 and
1
2
and
is
2
equal to
is
1
equal
by
to 1 by
6
6.
and probability
And
of s
probability
equal
of
to
S equal
3
to 3
is again
is again
1 by 3
1 by 3.
this is given
This
to
is
so this
given
is
to.
the
So this is the
probability mass
probability
function
mass
of this
function of
random
this random
variable
variable.
now what is
Now
the
what is the
expected value
expected
of
value
s
of S?
expected value of
Expected
s
value
is
of S is
simple now
simple now.
so
So
probability s
probability
equal
S
to
equal
0
to 0.
so 0
So
into
0
p of
into P of
s equal
S
to
equal
0
to 0
plus
plus
1 into
1 into
probability of
probability
s
of
equal to
S
1
equal to 1
plus 2
plus
into
2 into
probability of
probability of
s equal to
S
2
equal to 2,
3 into
3 into
probability of
probability
s
of
equal
S
to
equal to
3
3.
so this
So
will be
this
just
will be
0
just 0,
no issues
no issues.
what is the
What is the
probability of s
probability of
equal to
S
1
equal to
that
1?
is 1 by
That is 1
6 we
by
just
6
saw
we just saw,
plus 2
plus 2
times
times
s equal to
S
2
equal
that
to
is
2,
again
that is
1 by
again 1 by
6 plus
6
3
plus 3
times
times
1 by
1
3
by
we just
3 we
saw
just saw.
so 3
So
3 gets
3 3 gets
cancelled 2
cancelled,
3s are
2 3s are
6 this
6.
will be
This
equal
will be
to
equal to.
someone is trying
Someone
to
is trying
join
to join.
yeah.
Yeah.
This will
This
become
will
what
become what?
so this is
So
1
this
by
is 1 by
6
6
plus 1
plus
by
1
3
by 3
plus 1
plus 1.
this is
This
what
is what?
this will
This
be
will be
1 plus
1
2
plus
plus
2 plus
6 by
6 by
6
6.
6 plus 3
6
9
plus
by
3 9 by
6 3
6.
3s are
3
9
3s
3
are
2s are
9, 3
6
2s are
so this
6.
is
So this is
1.5
1.5.
so this
So
is the
this is the
expected value
expected
of
value
your
of
score
your score.
so
So
these are all
these are all
calculations simple
calculations, simple
calculation I
calculation.
mean it
I
is
mean it
lengthy
is
but
lengthy,
all the
but all the
calculations are
calculations
simple
are
I
simple.
hope
I
you will
hope you
agree
will
on that
agree on that.
so if you
So
hit a
if you hit
dart
a
on
dart
this
on this
dartboard
dartboard,
you should
you should
expect a score
expect a
of
score of
1.5
1.5
basically
basically.
so the
So
average
the
score
average
that you
score
can
that you can
expect is
expect
sort
is
of
sort of 1 by
1.5
1.5,
3 by 2
3 by 2.
I hope you
I
can
hope
see
you can
that
see that,
though it was a
though it
lengthy
was a
thing
lengthy
but
thing, but
throughout there was
throughout there
nothing
was
new that I
nothing new
did I
that I did.
always
I
changed
always
the
changed
limit
the
and
limit, and
I just
I
took this
just took this
integration every
integration
time
every time.
just change the
Just
limit
change the
and
limit and
calculated the
calculated the
probability
probability.
let me know
Let
if
me know if
something was
something
not
was
clear
not
I mean
clear. I mean,
it's possible
it's
that
possible that
you zoned
you
out or
zoned out, or
maybe
maybe
since I'm not
since
good
I'm
at
not good
teaching
at
I
teaching, I
don't
don't know,
possible that
possible that
I messed
I
up
messed
something
up something.
uh,
Uh,
by the way
by the way,
just feel free to ask any question. Okay, I mean, these tutorial sessions are designed for you. I mean, there's no point of being mute all the time. If you are not understanding and you're just sitting. Okay, we'll move forward. So let's look at another question. So okay, recording is going on, just making sure. Yeah, recording is going on. Yeah. So here is another question. So x is again this time a discrete random variable. Discrete random variable. Okay. Now you are given a table basically a probability mass function table. So x can take some values, right? Minus 2, minus 1, 0, 1 and 2. These are the possible values that x can take. Okay. And the probability of each one of them is given to you. 2k square, k, 1 minus 2k, 4k minus 1, 2k square. These are given to you. Okay. And the question that is asked to you is what is the probability that x is between minus 1 and 2. You are being asked what is the value of this thing. So I hope you will agree that to evaluate this probability you need to find the value of k. How do you find the value of k? By now it should be quite clear in your head. Whenever you see some unknown scalar in your probability mass function, just use one thing, that is the sum of all the probabilities should be equal to 1. Right? So probability of x equal to I summation I equal to minus 2 to 2, this should be equal to 1. And what is this probability? 2k square plus which is this thing plus k this thing plus 1 minus 2k this thing plus 4k minus 1 this thing plus 2k square. Right? This implies 2k square this will become 4k square plus minus 2k plus k minus k plus 4k. That will become 3k plus 1 minus 1 gets cancelled. There is no other constant, so this should be equal to 1. This is what is given to us. So k into 4k plus 3. Okay, sorry. So you just take this thing here. So this implies 4k square plus 3k minus 1 is equal to 0. And what are the roots of this equation? I have forgotten 4k minus k minus 1 this is equal to 0. This implies 4k times k plus 1 minus 1 times k plus 1 is equal to 0. This implies k plus 1 into 4k minus 1 this is equal to 0. Right? So what is k? Can either be equal to 1 by 4 or minus 1. However, if k is minus 1, then this probability will become negative, right? Which is not possible because probabilities are always greater than 0. So this thing is not possible. Right? And hence k should be equal to 1 by 4. So if k is equal to 1 by 4, we have this value of k. Now what is being asked? We are being asked what is the probability that x is between minus 1. So x is greater than minus 1 and less than equal to 2. So x greater than minus 1 less than equal to 2. What are the possible values of x that it can take? So it cannot be minus 1 because it has to be greater than minus 1. So the next thing is 0. It can be 1 since 1 is less than or equal to 2. It can be equal to 2 because the inequality includes equality. So 2 is allowed. It cannot be 3 or anything else because there is no positive values, right? So x. So these are the only values, right? So the question that we are being asked is minus 1 x less than equal to 2 is equal to probability of x belonging to this set 0 1 2, right? Now what is the probability? That is probability of x equal to 0 plus probability of x equal to 1 plus probability of x equal to 2. Now probability of x equal to 0 is given to us, that is 1 minus 2k, right? This is 1 minus 2k. probability of x equal to 1 is given to us, that is 4k minus 1. And probability of x equal to 2 is given to us, which is 2k square. Right, plus 2k square. Now you just simplify this. This is 2k square plus 4k minus 2k is again 2k. Plus 1 minus 1 is 0. So this is all. And now we know that the value of k we found out to be 1 by 4, right? So just put that thing 2 into 1 by 4 whole square plus 2 into 1 by 4. What will this value be? 2 by 16 plus 1 by 2, right? So 2 8s are so this is 1 plus 4 by 8 is equal to 5 by 8. This is your answer. Any questions? This was a simple question. Relatively, it was a simple question. No questions? Okay. So move on to the next question. This was with fifth question, right? So let's move on to sixth question. Allow me to drink some water. Throat has gone sore. By the way, can someone of you confirm if my voice is audible or not, or my screen is visible or not? Is there any issue? Can someone
audible and visual, sir.
Okay,
Yes,
thank
sir,
you.
it
No
is
issue.
audible.
Okay, thank you. So let's look at another question. Okay, so there is a LAN network, local area network. You must have heard of this word. Okay. And this LAN network experiences error. Experiences some error. So there is some shutdown that happens. Okay. So the probability of such errors, the number of such errors to be equal to k in 24 hours is given to be e raised to minus 3 into 3 raised to k upon k factorial. Now k can be equal to 0, 1, 2 or 3, so on, right? So this is a Poisson distribution. So basically what you are saying is x is belonging to some Poisson 3, right? This is given to us. The question that is asked to us: what is the probability that at least one network error takes place? So at least one network error takes place. That means that x should be x. The value of x should at least be equal to 1. It could be 2, it could be 3, or so on. But it should be at least 1. It should be greater than equal to 1. So this is probability of x greater than or equal to 1, right? Now this thing can be written as probability of x equal to 1 plus probability of x equal to 2 plus probability of x equal to 3 plus and so on, right? Now I will just add and subtract probability of x equal to 0 minus probability of x equal to 0. So if you look at this, then this entire thing, this should be equal to 1, right? Because probability of x equal to k, sum over k equal to 0 to infinity, that should be equal to 1, because sum of all probabilities should be equal to 1, right? That will become 1 minus probability of x equal to 0. Is this clear? I mean, I'm just using the fact that so one can also think of it as probability of x greater than 0 is equal to 1 minus probability of x less than or equal to probability of x equal to 0. So it's like these two events are complement of each other, so you can just take the complement because calculating this is easier as compared to calculating this, right? Now what is the
Now what is the
probability of
probability
x
of
equal
x
to 0?
equal to 0?
This is equal
This
to,
is equal
so
to,
just
so just
put 0
put
here, right?
0 here, right?
Just put
Just
k
put
equal to
k
0
equal to
here,
0
right?
here, right?
So
So
e raised to
e raised to
minus
minus 3
into
into
3 raised
3
to
raised
0
to
by
0
0
by 0
factorial.
factorial.
This is
This
equal
is
to 1
equal to 1
minus
minus e raised to
minus 3,
minus
3
3,
raised to
3
0
raised
is
to 0
1,
is 1,
and 0
and 0
factorial is
factorial
also
is
equal
also
to.
equal
So this
to.
is
So
equal
this
to
is
1
equal to
minus
1
e raised to
minus e
minus
raised to
3.
minus 3.
Now you can
Now
use
you can
your
use your
calculators
calculators to
this value,
calculate this
but
value,
yeah,
but
I won't do
I
it here.
won't do it here.
So this is a
This is
simple
a
question,
simple
right?
question,
Again,
right? Again,
nothing
nothing
very
very
high-fi.
high-fi.
Which question
Which
to
question
look
to
at
look at
next?
next?
Shall we look
Shall
at
we look at
some similar
similar
question?
question?
Okay,
Okay,
let us
let
see.
us see.
Okay, let's
Okay,
see what
let's see
happens.
what happens.
So
So
next question. This was the
This
sixth
was the
question,
sixth
right?
question, right?
So okay, do we
Okay,
have
do
time?
we have time?
Yeah, we have
Or
time.
we have time?
We'll see.
We'll see.
So let
So
us look
let
at
us look
another
at
question.
another question.
So the question is as follows. So x is a random variable which is distributed as Poisson
Poisson 4.
okay,
Okay.
and E is an event. So
So
E is an event such that probability of E probability of this event given that x equals to I is equal to 1 minus 3 raised to minus I. I can be equal to what? 0,
0,
1, 2,
1,
so
2,
on,
so on,
right?
right?
The question
The
that is
question
asked
that is
is
asked
what is
is what is
probability of E
probability of
equal
E
to?
equal to?
I hope the
I
question
hope the
is
question
clear,
is clear.
right? You
Right?
have a
You
random
have a random
variable
variable
and you have an
and you have
event.
an event.
The
The
probability of this event
conditioned
conditioned on this random variable
or
more
more
correctly this
correctly
event
this
that
event
x is
that
equal
x is
to
equal
I
to I
is given to
is
be
given to
this,
be
and
this,
your
and your
so this is a
so this is a
conditional
conditional
probability.
probability.
You are
You are
asked
asked
that what is
what
the
is the
total
total
probability of this
probability of
event.
this event.
So
So
here
so
we
here
will
we will
use
use
the
the
law of
law
total
of total
probability,
probability,
which says
which
that
says that
probability of
probability
E
of
is
E
equal
is
to
equal to
what?
what?
Probability
Probably
summation over
over
probability of
probability of
E
E
comma
comma
x
x
equal to
equal to I.
I goes
I
from
goes from
0 to
0 to
infinity.
infinity.
So this is
So
like
this is like
marginalization of
marginalization
x,
of
right?
x, right?
So
So
it's like,
it's like,
so I hope you
so I
have
hope
seen
you
this
have seen this
probability,
probability,
this
this
identity, right?
identity,
That
right? That
uh,
uh,
if you want
if
to
you want to
marginalize out
marginalize
one
out
random
one random
variable,
variable,
right?
right?
You just
You just
take sum
take
over
sum
all the
over all the
possible values
possible
that the
values
random
that the
variable
random
can
variable
take,
can
and you
take,
will
and
get
you will
the
get the
marginal
marginal
distribution of the
distribution
other
of the
random
other
variable.
random variable.
Now here you
Now here
can
you can
use
your
Bayes rule
Bayes
to
rule
split
to
this
split this
probability I
probability
equal to
I
0
equal to
to
0 to
infinity
infinity
probability of
probability of
E given
E
x
given
equal
x
to I
equal to I
into
into
probability of
probability
x
of
equal
x
to I,
equal to I,
right?
right?
So
So
I
so
just
I
use
just
this
use this
thing that
thing that
probability of
probability
A
of A
comma
comma
B
B
is equal to
is equal to
probability of
probability
B
of B
given A
given
times
A times
probability of A,
probability of A,
right?
right?
So I
So
am just
I am
using
just
that.
using that.
Why I am
Why I am
doing it this
doing
way,
it this
and
way,
this
and
can so
this can
so
so
another way to
another
write this
way to
could
write
be
this
that
could be
you
that
write it
you
as
write it as
summation.
summation.
Okay.
Okay.
Another way
Another way to
could
write this could have been
to write it as probability of x equal to I given e into probability of e. But notice that this won't help us because this is also unknown and this is what we are being asked actually. Right? This is what we had to have. So this type of decomposition won't help. You have to decompose it like this. I mean which decomposition you need to use depends on what information you have been given. Probability of e given x equal to y is given to you, and it is also given that x is a Poisson. So you know what is this probability of x equal to y is. So you have to be just clever here. I equal to 0 to infinity. This thing is given to you. What is it? 1 minus 3 raised to minus I, right? So this will be 1 minus 3 raised to minus I. And what is probability of x equal to y? X is a Poisson distributed random variable with Poisson 4. So this will be raised to minus 4 times 4 raised to I by I factorial, right? So now you have to basically calculate this sum. Can we calculate this sum is the question. I'm not sure. I can try, but I'm not sure if I can calculate. Just let me just do it. So e raised to minus 4 is a constant. I can take it out here, right? And I can take this summation and just write it this as I equal to 0 to infinity 4 raised to I by I factorial, right? Because it is just one here minus summation I equal to 0 to infinity 3 raised to minus I into 4 raised to I by I factorial, right? This is what it is. This will become e raised to minus 4 e raised to minus 4 summation I equal to 0 to infinity 4 raised to I by I factorial minus summation I equal to 0 by infinity 0 to infinity. So I can write this as 4 by 3 raised to I upon I factorial, right? What can we do here? So can I club this sum? Yeah, I can club these two sums. This will become e raised to minus 4 times summation I equal to 0 to infinity 1 by I factorial into 4 raised to I minus 4 by 3 raised to I. Will this help me in any way? Okay. One over 1 minus x and e raised e. Need to think about it. How to calculate this sum. E raised to minus 4. Okay. So do you know about this thing? So there's something called power series expansion. So e raised to x can be written as 1 plus x square by 2 factorial plus x cubed by 3 factorial plus so on. Do you know about this thing? This is called Taylor series expansion. Taylor series expansion. So basically we can look at this. So maybe ignore this thing. Ignore this part. Just take this here. So So this
So
can
this
be
can
seen
be
as
seen
this
as
is what
this is what
this is
this is
basically 1
basically 1
plus
plus
I
I
plus
plus
I can just
I can
replace
just
I
replace
by
I by
x by I
x
square
by
and
I
so on,
square
right?
and so on, right?
This is equal to
This is equal to
summation of what
summation of what
I
I
sorry
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 can you
can you
remove this
remove
thing?
this thing?
So this can
This
be seen
can be
as
seen as summation of
x raised
x
to
raised to
by
I
I
by I
factorial, right?
factorial, right?
I equal to
I
0
equal
to
to 0 to
infinity.
infinity.
So
So
you see this
you see
is
this is
nothing but
nothing but
instead of
instead
x
of x
it is 4
it is
here,
4
that's
here,
all,
that's all,
right?
right?
Instead of x
Instead
here
of
it is
x
4
here
by
it is
3
4 by 3
and
and
it fits this formula.
formula.
So
So
this
this
expression
expression
here can
here
be
can
written
be
as
written
e
as
raised to
e raised
minus
to
4
minus 4
times this
times
thing
this thing
is equal
is equal to
e raised
e
to
raised
4
to 4
because
because instead
instead
of
of
x
x it is 4 here,
it
so
is
this
4
will
here,
be
so
e
this
raised
will
to
be e
4
raised to 4
minus
minus
e raised
e
to
raised
this is
to
e
this
raised to
is e
4
raised
by
to 4
3
by 3
4 by 3
4 by 3
and this will
and this
become e
will
raised to
become e
4 into
raised
e
to 4
raised to
into e
minus
raised
4
to
will be
minus
just
4
e
will
raised
be
to
just
0
e
which
raised to
is
0
1
which is 1
minus
minus
e raised to
e
minus
raised to
4 into
minus
e
4
raised to
into e
4
raised
by
to 4
3
by 3
which will
which will
become
become
1 minus
1
e
minus
raised
e
to
raised to
4 by
4 by
3
3
minus 4.
minus 4.
This will be
This
1
will be
minus
1
e
minus
raised
e
to
raised
what
to
will this
what
be?
will this be?
4 3 is
What is it?
12, 4
12 4
minus
minus
12
12
minus 8
minus 8
by 3.
by 3.
Now you can
Now you
calculate
can
this
calculate
thing
this thing
using
using
calculator,
calculator,
but
but
yeah,
yeah,
this
this
is
is
the
the
value.
value. So
So what I
what
did
I
was
did was
I just
I just
simplified things.
simplified things.
I just
I just
used one more
used one more
technique that
technique that
I don't know
I
what
don't
this
know
sum
what
was,
this
but
sum
it
was, but
clicked
it
me that
clicked me
this
that
sum
this
is
sum is
exactly the
exactly
Taylor
the
series
Taylor series
expansion of
expansion of
exponential
exponential
function,
function.
and here
And
this is
here this
instead
is
of,
instead
so
of,
you can
so
just
you can
compare
just
it here,
compare it
right?
here,
So
right?
this
So
is
this is
summation x raised
summation
to y,
x raised to
instead
y,
of x
instead
it
of
is
x
4
it is
here,
4 here,
and here it
and
is
here
4
it
by
is 4
3.
by
So
3.
so this
this
is
this
actually
is
equal to
actually
e
equal
raised
to
to
e
4,
raised to
and
4,
this thing
and
is
this thing
actually
is
equal to
actually
e
equal
raised
to
to
e
4
raised to
by
4
3.
by 3.
And I just
And I just
substituted these two
substituted these
things
two
in
things in
here
here
in this thing,
in this thing,
and
and
the rest of
the
the
rest
things
of
are
the things
simple.
are simple.
I don't know
I
if
don't know
was
if
it
was
clear
it
or
clear or
there was
there
some
was
issue,
some
or
issue, or
it went
it went
completely
completely
you didn't
you
understand
didn't
it
understand it
completely.
completely.
Maybe you
Maybe
can
you can
just
just
say
say
yes or
yes
no
or
so
no
that I
so that
know
I know
that
that
Yes, sir. Understand, sir.
Okay, thank
okay, thank you.
you. Okay,
Okay,
so this was
this
one
was
question.
one question.
So maybe
So
we'll
maybe
solve
we'll
one
solve
last
one
question
last
and then
question
we
and
can
then we
end.
can
Okay.
end. Okay.
So this was
So
the
this was
seventh
the
question,
seventh
if I'm
question,
not
if
wrong.
I'm not wrong.
So let's
So
solve one
let's
more
solve one
question
more
and then
question
we
and
will
then we
stop
will stop
today's
today's
session.
session.
This is eighth
This is
question.
eighth
Okay.
question. Okay.
This is eighth
This is eighth
question.
question.
So okay. So here is a situation. Generally, when you travel in a flight, people book tickets, and if they don't want, so let's say if someone books ticket and suddenly he thinks that maybe I don't need to travel anymore, he can cancel that ticket. So when airplane companies, airline companies, when they know this thing, right, that people can actually just cancel tickets, right? So uh, in those situations, what they do is they, because they want to fill up all their seats, what they will do is they will, so let's say if they have 50 seats, they will sell more than 50 tickets actually, because they know that at the last moment some person can actually cancel their tickets. So they don't want to lose out on the number of tickets they can sell, right? So here is the situation. An airline there is some airline companies, and that it knows that probability of cancellation, that a person cancels a ticket is equal to 5%, which is 5 by 100. Okay.
Okay.
So and it has 50 seats. It has 50 seats. So what it does is it sells 51. It sells tickets for 51 seats. So it sells 51 tickets. Okay.
Okay.
And So
So
I hope you
I hope you
understand,
understand,
right?
right?
That amongst
That amongst
these
these
51
51
tickets,
tickets,
the airline
the airline
company
company
thinks
thinks
that
that
someone
someone
will,
will,
cancel the ticket
cancel the
at the
ticket
last
at the
moment,
last
and
moment,
hence
and hence
all their
all
seats
their
will still
seats
be
will still
filled
be filled,
even if
even if
that person
that
doesn't
person
come.
doesn't come.
So this is
So this
kind
is
of
kind
a
of
risk
a
that they
risk
take.
that they
Okay.
take. Okay.
Now
Now
the
the
question is,
question is,
uh,
uh,
what is the
what is the
probability
probability
that
that
there will
there will
be
be
seats
seats
available
available
for
for
every
every
passenger?
passenger?
So
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 basically, let's say
basically,
they
let's say
sell
they
51
sell
tickets,
51
okay,
tickets, okay,
and all of
and
the
all of
51
the
people
51
come. No
people
one
come. No
actually
one
cancels
actually
the ticket.
cancels the ticket.
If that is if that
If that
happens,
happens,
then
then
actually, since they
actually,
have
since they
50
have
seats
50
and
seats and
there will be
there will
51
be
people, there
51
will be
people,
one
there will be
seat
one
that will
seat that will
be
be
left out, right?
left out, right?
So there will be
So there
one
will be
person
one
who
person
won't
who
get
won't
any
get
seat,
any seat,
basically. So
basically.
what is the
So what is the
probability
probability
that
that
doesn't happen?
doesn't happen?
So
So
let's say
so
the
let's
number
say the
of
number
people
of
that
people
are
that
on
are
board
on board
are equal
are
to
equal to
x,
x,
is denoted
is
by
denoted
x. So
by
what is
x.
the
So what is
probability
the
that
probability
x is
that
less
x
than
is less
equal to
than
50?
equal to
That
50?
is the
That is
probability
the
that is
probability
being
that is
asked.
being asked.
I hope you
I
can
hope
see,
you can
because
see,
if
because
x is
if
less
x
than
is less
equal to
than
50,
equal
then
to
every
50, then
person
every
will get a
person will
seat.
get a seat.
But if
But if
x is
x
equal to,
is
let's say,
equal to, let's say,
51, there will be
51,
one
there will be
person
one
who won't
person
get
who
any
won't
seat,
get any
right?
seat, right?
So this is the
So this is the
probability that we
probability
are
that we
asked,
are asked,
and that
and
is
that is
equal to
equal
what?
to
1
what?
minus
1 minus
probability of
probability of
x equal
x
to
equal to
51,
51,
right?
right?
Because this is
Because
the
this is the
complement, right?
complement, right?
And
And
what is the
what is
probability
the
that x
probability
is
that
equal
x
to
is equal to
51? So
51? So
now
now
you can
you
think,
can
use this
use this
probability, right?
probability, right?
So the
So the
all
all
51 of
51 of
them should
them should
basically
basically
buy the
buy the
so all
so all
51 people who
51
have
people
bought the
who have
ticket
bought the
should come
ticket
to the
should come
flight.
to the flight.
So what is the
What is the
probability of that
probability of that
happening? That will
happening?
be
That
1
will be
minus
1 minus
probability.
probability.
So this
So
thing
this
will be
thing
equal
will be
to
equal to
so this is actually a binomial random variable. You
variable.
can
You
think
can
of it
think of
as
it as
uh,
uh,
you can just
you can
write it
just
as
write it as
0.95. So
0.95. So
because
because
no one
so no one
cancels, right?
cancels, right?
Probability of
Probability of
cancellation is 5
cancellation
by
is 5
100.
by
So
100. So
probability of
probability
not
of not
cancellation is
cancellation
1
is
minus
1
5 by
minus
100,
5
which
by
is
100, which is
95 by 100,
95 by
which is
100, which is
0.95,
0.95,
and you
and
want
you
all
want all
51 of them
51
to
of
be
them to
this
be
thing.
this thing.
So this thing
So
can
this thing
actually
can
also be
actually
written
also
as
be written as
51
51
C51
C51
times
times
0.95 raised
0.95
to
raised to
51
51
times
times
0.05 raised to
0.05 raised to
51 minus
51
51.
minus
So
51.
this is
So
like
this is like
x is
x
actually
is
a
actually a
binomial random
binomial
variable.
random variable.
Nomial
Nomial
random
random
variable
variable
with
with
51 this
51
thing,
this
and
thing, and
probability of
probability of
success is
success is
0.95.
0.95.
This is what it
This
is.
is what it is.
And if you
And if you
calculate this,
calculate this,
so
so
you can
you
calculate
can
this
calculate
using
this
some
using some
calculator on your
calculator
own,
on
right?
your own,
I
right?
cannot
I
calculate
cannot
this on
calculate this
hand
on
right now.
hand right now.
So this is
So
what
this
it
is
is
what it is
basically.
basically.
So this is
So
just
this is just
another
another
sort of an
sort of an
interesting
interesting
application of
application of
this
this
probability.
probability.
So you can
So you
see
can see
how
how
people
people use
keep
keep
make use of
make use of
probability in different
probability in
settings.
different settings.
So okay, so
So
these
okay,
are
so
all the
these are all
questions
the
that I
questions that I
intended to
intended
solve
to
today.
solve today. Uh,
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 Please tell
Please
me if
tell
there
me
is
if
any
there is
doubt or
any
any
doubt or any
question
question
I can
I
solve.
can solve.
Otherwise, we will
Otherwise, we
end
will
this
end
meeting.
this meeting.
So yeah,
So
now
yeah, now
I'm
I'm
open for
open for
questions.
questions.
If
If
there are no
there are no
questions, we
questions,
will end
we
the
will end
meeting.
the meeting.
Are there any
Are there any
questions?
questions?
You can just
You
say
can just
no
say
if
no
there
if
are
there are
no
no
questions. Okay.
questions. Okay.
And please
And
don't
please don't
hesitate to
hesitate
ask
to ask
question if you
question if
have.
you have.
So no
So no
questions, I
questions, I
assume.
assume.
I don't know if I was not good at teaching or something, but okay, there are no questions. So okay, so maybe we will end the meeting. Okay, I will stop the recording. Thank you for joining. Okay, have a nice day. Goodbye.